It is 8 o'clock in the evening, and your internet has quietly gotten worse. The same video that streamed perfectly at 2 in the afternoon now stutters and spins its little loading wheel. Your speed test shows a number that would have embarrassed your provider this morning. Nothing changed inside your house. Same router, same devices, same bill you are paying. So why does the exact same connection feel slower at the exact same time almost every single night? The answer has almost nothing to do with your house at all. Internet providers do not give every customer their own private wire all the way back to the wider internet. That would be enormously expensive. Instead, a whole neighborhood of homes typically shares one local connection point, sometimes called a node, before that shared line joins the larger network. During the day, this barely matters. Most people are at work, at school, or simply not streaming video, and the shared line has far more room than anyone actually needs. Then evening arrives. Suddenly, entire streets of houses are all doing the same thing at once. Streaming a show, downloading an update, gaming online. Everyone in the neighborhood is now trying to use the same shared pipe at the same time for the exact same few hours of the day. Engineers call this peak hour congestion, and it behaves exactly like rush hour traffic. A motorway is not slower at 5 in the afternoon because the road itself changed. It is slower because a fixed amount of road suddenly has far more cars trying to use it at once. Your internet works the same way. The line is not smaller at night. There are simply more people trying to squeeze through it. This is what engineers call a contention ratio. Providers plan for the fact that not everyone uses their maximum speed simultaneously, because statistically, they never quite have. But evening streaming habits push a shared line closer to that theoretical limit than almost any other point in the day. There is a second part to this problem, and it happens much closer to your screen. Even once your data reaches the provider's larger network, it still has to travel to wherever the video or file is actually stored, potentially crossing multiple other companies' networks along the way. If a popular streaming service is sending video to millions of households at once, in the same evening window, the connections between networks themselves, not just your street, can become the bottleneck. This is why services like Netflix build their own dedicated delivery systems, placing servers directly inside internet providers' own buildings, specifically to shorten that last difficult stretch during the busiest hours. It genuinely helps, but it cannot make evening demand disappear. It can only make the trip shorter once the data actually gets moving. Then there is a problem hiding inside your own home network. One most people have never heard of, called buffer bloat. Your router and modem hold a small reserve of data in memory, called a buffer, to smooth out tiny interruptions in your connection. Under light use, this buffer is helpful and invisible. Under heavy evening congestion, that buffer can fill up and stay full, meaning your data is technically arriving, just sitting in a queue longer before it is actually used. This is part of why your connection at night does not just feel slower. It feels laggy, with an odd invisible delay even on tasks that should be instant. So when your evening internet crawls, 3 separate things are usually happening together. Your local shared line is more crowded than it has been all day. The wider path your data travels is also more crowded, with everyone else's evening habits too. And your own equipment is quietly holding on to extra data longer than it needs to, waiting for its turn. None of this means your provider lied about your speed. It means the number on your bill was always a best case, measured for a quiet moment that evening rarely is. There are small things that genuinely help. Wired connections skip a fair amount of the congestion happening over crowded household Wi-Fi bands, since neighbors' routers are competing for the same wireless airspace too, not just the same wired line further upstream. Some newer router software actively manages buffer bloat, prioritizing smaller, time-sensitive data like video calls over large background downloads, which cannot fix a crowded neighborhood node, but can at least stop your own equipment from making the wait feel worse than it already is. None of it changes the basic shape of the problem, though. Millions of households, all reaching for the same few hours of free time every single evening, are always going to strain a network built around the assumption that not everyone arrives at once. Now you know.